Soundproofing is kind of an art. It's not as simple as buying something and slapping it on your walls. And the word soundproofing is a bit of a loaded term. You could mean deadening sound, so you can record podcasts with that signature radio sound. Or you could mean isolating a room from outside noise, which is an entirely different process. Or you could work on reducing resonance, echo, or just certain frequencies. In my case, I wanted to build kind of a sound cocoon in the middle of this space so I could record anytime, day or night, even if my AC is running. There are so many different sources of sound in our world, whether it's a river, a highway, a giant HVAC system, or maybe just the neighbor next door playing drums. And every sound has its own characteristics, like the train tracks that run outside. They transmit sound through the earth, meaning if I wanted to soundproof my room from that, I'd need to spend thousands of dollars isolating the floor entirely. Gamers Nexus actually did that in their new anechoic chamber, but I'm sure the price for that thing was astronomical. In reality, I'll just stop recording when a train rolls by, or live with a little rumble and maybe roll off the low end in post. But today's video is short and sweet. I'm going to give a quick overview of where we are today now that framing is complete. I'll talk about some of the things we did to make this room as sound isolating as possible on a bit of a budget. I should note most of these things are only possible when you're building a new wall. If you already have a space built out, you have to get a lot more creative to get the same level of sound isolation. And starting outside the studio, this little room isn't getting sound treated. This front welcoming space has metal stud walls and a door. You can see the wall is just bolted down to the floor and tied right into the ceiling, and there'll just be drywall on both sides. And the server room in the back here will be the same, though we will throw some Rockwell insulation over the ceiling. These walls do deaden sound a little, but only a little. STC ratings aren't everything when it comes to soundproofing, but they're a handy guide. And a standard wall like this one should have an STC rating of about 30 to 35. A really good studio wall would give you a rating in the 70s, so about double that wall. But we were aiming for a rating in the 50s or 60s. We have metal studs, and this fiberglass insulation will be stuffed between them. On the front and back of the studio, there's also resilient channel. This metal track screws in this way so the drywall is actually floating just in front of the studs. But it's really important you install everything right. You have to make sure to install it so it hangs upward, like this. That way the drywall kind of pulls down on the channel to create that gap between the drywall and the metal studs. The inner wall will just be drywall on the studs, but even here the drywall won't touch any other surface besides the wall. The top and bottom will have a small gap, and this detail is really important. That gap will get some acoustic caulk to isolate the drywall itself from the floor and the ceiling. And to isolate the wall structure, there's this other fancy trick. This rubber is compressed closed cell neoprene, and it isolates the wall itself from the floor and the ceiling. It makes it so the entire wall is, in a sense, floating. Only very low frequency vibration can get into the wall, like rumble from a train or a huge truck rolling by. I really wanted to show you these things before everything's covered up because the best way to get effective soundproofing is to do it in the structure itself. If you already have a finished room, it's a lot harder to isolate certain sounds. Like, I remember Linus and Jake on LTT had to do all kinds of crazy things to get server room noise down in their new lab. In this build, my server room's walls won't actually be touching the studio. You can see this gap here where the walls are decoupled. That makes a huge difference, along with the extra treatment we'll have up in the ceiling, and hopefully I'll never hear the server room from the studio at all. And speaking of that ceiling, if you take a look up there, it doesn't look too impressive right now. There's just T-bar, and that's the same stuff I ripped out a couple weeks ago. What's up with that? Well, this T-bar is actually going to be for a drywall ceiling, and above that we'll put this rock wool, which provides extra fire, water, and most importantly, sound protection. So the ceiling will have rock wool on top of drywall hanging in the new ceiling grid, and then under that there will be a new drop ceiling where the lights will go. That detail's a little tricky, but I'll show you more of that when we get to it. But the main goal there is to isolate the big HVAC unit on my roof from the studio space. Hopefully, and we're not 100% sure on this, but hopefully there won't be much sound that gets through when the unit kicks on. At least not enough to be picked up on a mic in the studio. And if that works, it should also work for things like big rainstorms. We'll see. One thing to keep in mind too is every hole you make has to consider sound isolation. Like, what about those huge door frames? They're giant holes, and outside of putting on one of those Tron-style doors,
now that is a big door.
There's no practical way to build a door as good as the wall for sound isolation. But we did consider the doors, and I'll hopefully get to show you how that framing works once it's time to install doors and trim. And electrical and HVAC? For electrical, we're limiting the penetrations, especially in the front and back walls, and we'll be sealing up each outlet so sound can't leak through the cracks. For HVAC, the plan right now is to put flex duct in the front wall and more duct from the back wall into the plenum space above. The key there will be getting the right bends to prevent sound from leaking in through the ductwork. We'll also try to prevent hard 90-degree bends or any obstructions at all, because that creates turbulence, and turbulence generates more sound. But the funny thing is, all this work, all the rubber, the resilient channel, the spacing, the ducts, that's all meant to isolate this room from the outside world. The goal there is to get this room as quiet as possible. But that doesn't even begin to help treat the room and make it a good recording space. Once we have drywall up and some doors on the room, I'm going to do a test to see what the ambient sound level is. It was something like 35 decibels before, so hopefully it's even a little less when we're done. My basement studio is something like 30 decibels and 32 when my HVAC is running, so that's pretty decent for recording. But the room here is going to be an echo chamber with 4 hard walls and a hard floor. After we build this thing, I'm still going to have to figure out the best way to sound treat it. I have some of these 700 series Owens Corning fiberglass panels in my home office, and I have a few spares from an old radio studio I can install. But there's that, sound treatment blankets, carpet, ceiling tiles. There are a lot of different things you can do to treat a space, and I'll definitely be working on that over time. But it's a lot easier to treat the inside of a space than to try stopping sound from outside getting in. And that is why I spent a bit of extra time and money up front working with an architect and a builder to make sure the structure itself is part of the studio space. Until next time, I'm Jeff Geerling.